Okay, so we're gonna do things just like slightly differently today because I don't think I need to be writing down word for word what goes in your notes because you guys are basically doing it before I even get to saying it anyway. So I'm going to go over the PowerPoints with the notes on it, but it's going to be your guys' job to do the copy and pasting over or the typing it in. I'm not going to type it on mine anymore. Does that make sense?
Yeah.
So instead of me like consistently going back and forth between the note sheet and the PowerPoint, I'm just going to review the PowerPoint, talk about it more in depth, but you guys are going to need to fill out the note sheet. So you're going to have both of them open probably to do the copy and pasting, but I do check that they're done. Some of them are graded. I'm not going to tell you which ones I'm grading, but all of them need to be done. Some of them I'm checking to make sure you're completing. Others I'm just checking to make sure that you're following along. But some of them are for a grade. So you need to make sure you are completing them. If you did not complete the ones before this, you should probably go back and do that. So we're going to finish up our food chains one today. The one from yesterday, right? Yeah, so we started yesterday. So on Google Classroom, if you scroll down to science, we started the food chain notes yesterday. So go ahead and get that open. And you can open the PowerPoint as well. We did about half of it, right? We stopped at food webs. So we have the next 2 pages of the food webs to fill out. Okay. There are some parts here where it says to draw the arrows and stuff. You will not need to draw the arrows. That's okay. We'll survive without that. So, yeah, so I'm going to go to the correct spot on our PowerPoint. And I'm just going to kind of talk through it, give you guys a little bit of time to copy and paste things over, but I'm not going to do any typing anymore because that just seems to take a long time. And I am 100% sure that you guys are fully capable of finding the correct word to go in the blank. Right? So I'm going to leave it to you guys to finish out the notes and type it on your own, but I am going to review the PowerPoints with you. So we are starting at the section called Food Webs. If you're looking at the slides, we're starting on slide number 10. So food webs are a more intense food chain, basically. A food chain is not a realistic representation of the feeding relationships that happen in natural environments. In natural environments, organisms will feed on or eat more than one thing. So yesterday we talked about the rabbit eating grass, a snake eating a rabbit, and a bird or the owl eating the snake. That's not the only things that they eat. They eat other things too. So the food web incorporates all of those other things that they eat as well. So it creates a complex feeding interaction between many, many organisms. This, yeah. Huh? Yeah, on the game yesterday, if you got to the place where it was like all kinds of different animals and arrows, that would have been a food web, but we hadn't talked about it yet. So the complex web of interactions is called a food web. The food web shows how organisms are part of multiple food chains and how they eat or feed on different things. So things that eat all kinds of different things. Okay? So I'm going to go grab my water bottle. I'll give you guys about 30 seconds to do this slide really quick. Okay. Next slide. Food webs illustrate the links between all organisms and an ecosystem. So it's going to say the wolf and like the owl. So in this case, the wolf at the top, the owl, and the snake are all the top predators. predators, the little the grass and the bush at the bottom, or the producers, they get eaten. Then you got the deer that eats the grass. The rabbit will eat both the grass and the bush. The cricket will eat just the bush. And then different things eat the rabbit, different things eat the cricket. So the arrows still show where the energy is going, but it also shows what eats what, right? So if you look at the snake, what does the snake eat? Good, it'll eat the frogs, the bird, all kinds of different things. Okay. So that second bullet point says, a food web demonstrates how feeding habits of one organism affect other organisms, even if it doesn't directly interact with it. Okay. Go for about 30 seconds on this slide. I don't think you guys need too long. And just know that you can always go back to this and finish typing them in later. This is slide 11. Alrighty. Next slide, more about food webs. They also show how organisms adapt to their feeding habits to change their food sources. So if a primary consumer is removed from the ecosystem, so like all of this one species goes extinct, there will be changes to the populations of another organism. So a plant that was eaten by the one that got removed, that died out, might flourish. There might be tons of that plant now. The population of the organisms that feed on the primary consumers must feed on a different food source now. If the organisms cannot adapt to eat a different food source, then they might starve. So a really good example of this is in Yellowstone National Park in the 90s. Basically, there was a ton of deer, like a lot of deer. And they were eating all of the plants in Yellowstone, and it was really hurting the ecosystem in Yellowstone National Park. So what they did is they introduced wolves to the environment. So they put wolves in that environment after that. Those wolves started to eat the deer. There were less deer, so the plants that all the deers were eating started to grow more, and the ecosystem kind of stabilized back out. Does that make sense? A little bit of like how the interactions work there. Taking that as a yes. Okay, I'll give you about 30 seconds here. All right. Next one. So this is just kind of like a what if. Is this on your notes? No, I don't even know. Yeah, this part is. So what do you guys think would happen to the bird population? Happen in the bird population, giraffes. If, okay, let's try that again. Okay, so you got the bird right here, right? This blue jay thing. If this population basically went extinct, what would happen to the things that around it? What would happen to the owl if this bird population went extinct? Not the frogs. What else does the owl eat? The owl might eat more bunnies because the bunnies are still around. And what if there's less bunnies? What would happen to all of these plants? Good. There would be a lot more plants, right? Because they didn't get eaten. What about the grasshopper? So we have the bird here. The bird goes extinct. What happens to the grasshopper? There's more grasshoppers because there's not as many birds eating it. If there's more grasshoppers, what happens to this bush that it eats? There's a lot less of these bushes. Okay. So the elimination of... Go ahead.
Do we do both food webs?
Uh,
Because there's two of the same ones.
no, you don't need to do both.
Okay.
Yeah. Okay. That's fine. So basically, this is showing that if you take out one animal, one type of species in your ecosystem, it's going to affect a lot of the different things in your ecosystem, right? If this bird goes extinct and the crickets eat up more of the bushes and stuff, and there's a lot of grass, there might be more deer, and then the wolves might be overrun. There's all kinds of different scenarios that could happen. Okay? So does it ask you to answer that question on there? Yeah, so I basically just talked through it, so hopefully you guys got an answer on that one. Yeah. Okay. All right, our next slide. Here's your answers. Okay. Owls would eat more rabbits, and snakes would eat more frogs. There would be, you can copy and paste it, that's fine. There would be more grasshoppers since there's no birds to eat them. Foxes would compete. Oh, that's a fox, not a wolf. All right. I guess I could see that. Anyway, foxes would compete with the owls to eat the rabbits, which would decline the fox's population. So there's a lot of different things that could happen. Right? Our next slide. Oh, is there not a next slide? Oh. Good timing then, but we're not done for the day. So that means that we finished up this, what is this called? The note sheet, which means you can turn it in when you finish this note sheet. I'm going to give you guys like 2 minutes. Finish this note sheet, please, and get it turned in, and then we're going to move on to another one that has posted. That was all for the food chains one. We have more that we're going to do. Yeah, once you finish up the food chains note sheet, you can turn it in.
Are these all like all of the classes?
Mm-hmm. Are they talking about it again? Where basically you're finishing up the food chains notes and turning it in. Once you finish the food webs part, yep, turn it in. This part? That was part of the thing. It's on that last slide. It might have just been copy and pasted twice. Just ignore the pictures and fill out the lines. All right. Is it short? Okay, good. All right, so I'm going to close out of the food chains one. Make sure you finish this. It is one of the ones that I plan on grading, so this is one of the important ones. Kind of longer, so make sure you get all that filled out. I'm going to go ahead and close it. And now, while we were talking, we had one post that's called Energy Flow Through the Food Chain Notes. So yay, we get more notes.
Yay. I think we can this one.
Yeah.
I finished them all today.
All right. Okay, so let's go to open those. I already have the Energy Flow PowerPoint open, but we have our note sheet as well to open. Yeah, we share it. The teachers share this, and then you guys can see it. So yeah, Miss Cardani and Miss Milligan are on it. Oh, and someone else. Miss Mills is down here at the bottom. So, on mine, not yours. So if you look at the screen, I can see it on mine because we share the document.
Oh, I see mine too.
Yeah.
I see all of them.
Yeah, me. I was like, that's me.
Wait, do we close the slide or and open another one?
Yes, we have a new set of slides that got posted. a new PowerPoint called Energy Flow Through the Food Chain Notes. You can open up that notes sheet, the Google Doc, and then we have the PowerPoint that I'm going to go over it while you guys do your copying, pasting, or typing if you're just typing it in. Okay? How are we doing online? Is this okay for you guys? I figure you guys are doing all right with it.
Yeah, good.
Okay. All right, so
Yeah.
I'm going to start going through this PowerPoint then. So, our first slide, energy flow through a food chain. We often focus on how energy flows from one organism to the next in a food chain. As we said yesterday, the energy in a food chain originates or starts with the sun. Basically, all energy needs to start with the sun. Plants make food using the sun's energy, the photosynthesis process, right? To do this, plants transform light energy into chemical energy, which is stored in the bonds between the atoms that make up food, sugar. So that's a lot, but basically that's the process of photosynthesis. They store up the energy in their leaves and stuff, and then the animals come and eat it, and the energy starts to flow through the food chain. But it does decrease as it goes through the food chain. Good. So the plant will start off with 100% of the energy from the sun. The rabbit will eat it and have like 75% of the energy left from the sun. Then the snake eats the rabbit, and the snake will have like 50% of the energy from the sun. And then the owl will eat the snake and have about 25% of the energy left from the sun. The owl will die, and it will be decomposed and eaten by the decomposers. And the plant will grow right out of that, and the whole process starts over again. Okay? So I'll give you about 30 seconds for this one. Mm-hmm. Alrighty, next slide. So the next stage, the animals will feed on the plants, right? So the rabbit will eat the plant. When they eat the plants, the energy from the plant is passed to the animal. So the energy is transferred from the food, aka the plant, to the animal that ate it. Okay, and then animals will feed on those other animals that ate the plants, and so on. So when these animals feed on other animals, so when they eat them, the energy is transferred from the food that they're eating to the animals that are eating it. Okay? So the energy goes from one animal to the next as it gets eaten by another animal. All those poor animals. And go ahead and be doing those. All right. Next slide. So now it's telling you like actual percentages. So as the length of the food chain increases, so the longer the food chain is, the amount of energy passed from one organism to the next one will decrease. So only 10% of the energy is passed from one organism to the next in the food chain. So each time something eats another thing, they only get 10% of the energy that that other thing had. So that is pretty much why food chains can't go on and on and on forever, because it runs out of energy eventually. There's less energy each time something gets eaten. It goes down by a power of 10, which technically you guys learn about in math in 5th grade. Powers of 10. So, only 10% of the energy is passed from animal to animal, or plant to animal in some cases. Okay. How are we doing on this one? Am I going too quick, or is this okay?
You're going a bit too fast.
A bit too quick? All right, I'll slow down just a little bit. I'll give you guys about a minute to just kind of catch up. I'm going to check on the people in here, and then I'll get going again.
Wait, what are we doing?
Just catching up to this slide. So get everything posted on your notes until this slide at least. Okay? Alrighty. Let's look at our next slide. Yeah, Charlie. Yes, you need to do that one. The answers are on the slides though too. Yep. Okay, so our next slide here says that when a consumer eats another organism, so it eats its food, only a small fraction of the food it eats will be used for growth. So only energy in food used for growth is available for food for the next organism in the food chain. So when an organism eats its food, 50% of the food is not digested and exerted as waste. The other 50% is digested and absorbed into the body. So basically, they get 10%. Yeah, but 50% of it goes away as waste, right? But still 10% of it goes as energy into the next organism. Yeah. So basically how it goes. Probably having one now, hopefully. Yeah. I can just leave this here as long as yes. You guys are gonna hear this for a few minutes. It's for dibbles. All right, how are we doing? Ready for our next slide?
Almost on.
Okay. Did you finish the food chain one? Yeah.
Yeah, you can go on.
All righty. Okay, so our next slide here, we have a lot more about the food. But Elijah, this one also answers your question too that you were asking me about the food, the energy. Most of the energy in food is used to fuel the life function of an organism. Energy flow in the food chain. Some of this energy is lost as body heat. So we give off body heat and that some of our energy is lost. 10% of the food that we eat is used for growth. So how we grow as human beings. It's used to build muscle, fat, and tissue that is also consumed as food, assuming that we're animals. Nobody really eats us, but
I finished the whole thing.
good.
Turn it in.
Yeah. Only energy in body tissues is available as energy in food for the next consumer. Therefore, only 10% of the energy in an organism can be transferred to an animal that eats it. So only 10% of the energy of the things that gets eaten. So let's say a lion, or I don't know how to say it. Yeah, let's say a lion eats a gazelle. That's good. Yeah. It eats like the tissue and stuff, right? It's not going to eat the bones and the hooves. It eats like the meaty parts of it. The meaty parts, the tissue parts of that gazelle hold 10% of the energy. So that lion is only getting 10% of the energy from the gazelle. Okay. Wait a minute.
What do I do now?
We're going to do one more in a few minutes. So we're almost done with this one, and then we'll have one more to go. Huh? Are we almost done? Is there one more slide? I think one more.
Can I start on the next one?
Is it up?
Is it energy period? Pyramid?
Mm-hmm.
Yeah.
Oh, this is the last slide. Okay, so I'm going to give you guys about 2 or 3 minutes. Once you finish up with this note sheet, you can turn it in. Energy flow in a food chain. So basically, we're just copy and pasting all of our notes. If I'm going too quick, it's totally fine. You can finish it up later. If you want to do it later and listen to me talk about it instead, that's fine as well. You just got to make sure you copy and paste it over and turn it in. Okay? I'm not requiring you to do it immediately, although it's nice if you do it immediately, right? And then you don't have to worry about it. But you get, there's one more. Sorry, there's so many. I'm just gonna say I do not plan science. One of the other teachers plans science, and I just do what she says. I plan the math, so you guys can blame me for the math stuff. Huh?
Is it energy pyramid notes?
Yep, that's the next one we're gonna do. Okay, so once you finish with the energy flow in a food chain notes, you can click turn in. Okay. Huh? This one, yeah, this one's only one page as well, the next one. There's so many notifications on this one. Wow. All right. So we do have one more thing. This one I think is a little bit short too, right? This one's 1 page long. So last one for the day. We have more tomorrow. Sorry. My hope is that maybe tomorrow I could just give it to you guys to do on your own time. and we can like watch Bill Nye or something instead. That would be better, right?
Yes.
We'll see. I don't know what Yoshi's doing, but I would prefer that he didn't distract everybody like he has been.
Well, the last time I watched my mom upload, I had to watch it again, and I watched it again after we finished my work. We kept asking.
Alrighty. So energy pyramid is our next one. You can open up your PowerPoint and the Google slide or document so that we can get it all typed out. And this one is it's 1 page long. Not too bad. A couple of things to fill in there, right? A little bit of a hint, nudge, nudge. This is when I'm grading, so make sure you complete this one. Okay, so I'm gonna go ahead and get started. Are we good online? Yoshi, I'm gonna need you to stop or I'm gonna remove you from the meeting. Thank you. Now, are we good? Are we ready for our next one? Do we need a little bit more time online? How are we doing? Doing good? Tired? I can't help you with the tiredness. Sorry, Lauren. Yeah, everybody in here's tired. Yeah. We're almost done. Okay, one last one. So we're gonna get going so that we can head out and not do this anymore. So energy pyramid. Last one. Trophic levels. A trophic level is the position of an organism in the food chain. It is another way of describing what an organism eats and what eats it. So we use this term to describe the energy transfer from one organism to the next in a food chain. And if you look at the pictures, the plant is the first trophic level. It's the one that has the most energy. The rabbit is the second trophic level. It only has 10% of the energy. Hang on, I'm getting a phone call. Oh, okay. Fine. They come up. Whatever. I'm not annoyed by it at all. Okay. So the plant has 100% of the energy at the trophic level, first trophic level. The rabbit then has 10% of the plant's energy at the second trophic level. Then the snake is at the third trophic level and has 10% of the rabbit's energy. And then finally we have the owl at the fourth trophic level. This one just goes in order, 1, 2, 3, 4, right? And that has 10% of the snake's energy after it eats the snake.
So they all get 10%
Of the previous animal's energy.
energy?
No, they all get 10% of the previous animal's energy. So it actually goes down exponentially. So technically the plant has 100% of the energy, right? When the rabbit eats it, the rabbit then has 10% of just 10%. That's its energy, 10%. Huh?
The rabbit just wasted 9%. So 9% of energy is in them?
No, 90% of the energy got pooped out by the rabbit. It's wasted. Yeah. Yeah. And then so the rabbit has 10% of the energy. Then when the snake eats the rabbit, there's only 1% of the energy left because that's 10% of 10. And then when the owl eats the snake, then there's only 0.1% of the energy left. That's why food chains can't go on forever and ever, because notice that it gets smaller every single time that something eats it. You're going to run out of energy eventually. Okay? Are we good with this one? Ready for our next one? Need about 30 seconds. Yes, and then fill out your notes when you get back, please. Okay. Alrighty, our next slide. More about trophic levels. The first trophic level includes the producers, so the plants. The first trophic level is typically always plants, the producers. The second level, or the second trophic level, will include the primary consumers, which are typically herbivores, yeah, they're all herbivores. Some of them are omnivores. Then the third trophic level will include the secondary consumers. Those ones are usually herbivores, or no, not I meant omnivores because they'll eat plants and animals. Okay. Huh? Yeah. Okay, we'll do about 30 seconds or so here. Oh, there was a video. I was supposed to show you guys a video. We'll watch it after. Well, when you watch the video, you don't have to type or anything. So, alright, next slide. Here we go. Each trophic level of a food chain contains 10% of the energy in the trophic level before it. So the second trophic level of the food chain will contain 10% of the energy that the first trophic level had. The third trophic level will contain 10% of the energy that the second trophic level had, and so on. So it's always going down by 90%, basically. Being reduced by a power of 10.
Can I turn it in?
Yeah. So when you look at the numbers underneath the animals in this one, the first trophic level is that plant that has 1,000 energy units. If you divide that by 10, you get the amount of energy that the rabbit has, 10 or 100 energy units. If you divide 100 by 10, you get the 10 energy units that the snake has. And then finally, when you are looking at how much energy the owl has, you divide 10 by 10 and you get 1 energy unit left. 1 divided by 10 is 0.1. 1/10. Let's see, what would eat an owl? I don't know what eats an owl. I don't know either. Do eagles eat owls? I don't know. But yeah. Okay, I'll give you guys about a minute to work on this one. I mean, I don't think a cat would really eat an owl. They usually get like little birds, not an owl. I feel like an owl could pick up a cat and carry a cat away.
So you know how I tell you that we have a farm right across our house?
Yep.
Well, by a barn down about, I'd say, half a mile away,
Mhm.
there's an owl. There's 2 owl nests, and you'll sometimes find owl pellets down there.
Yeah. When I was in 6th grade, actually, we went to a science camp. Like we had chaperones and stuff, and we spent the night out in the woods in these cabins, and we got to dissect owl pellets.
What do they do at the 6th grade camp out? Like, do they sleep in?
Oh, for our camp out that we do?
Yeah.
I don't know if we're gonna get to do it this year, but for our 6th grade camp out, you guys stay in tents. So you pick your own tent. There's 10 kids per tent. Very full.
It is
But
very.
it's not always 10 kids per tent. Sometimes there's less. It depends on how many of your friends you want in your tent, I guess, and how many tents we have available.
Do we have to bring our own tent?
No, we have tents.
Okay.
Then you don't get to go. The Forest Service is out there with us, so they make all of our meals. They give us breakfast, lunch, and dinner. They also do cool stations. They bring out a big fire truck, like the Woodlands fire truck, and they show us that thing. There's BB guns and an arrow archery
BB
thing.
guns are so fun.
It's super cool. I hope we get to go. I always go. I think it's so much fun. But
I have a BB gun. and a 22 rifle.
Yeah.
I have 2 BB guns.
Cool.
I have a
Okay,
BB
wait.
gun
Let's
and a
focus
rifle.
on. We're almost done. Next part. More about trophic levels. Less energy is available to organisms in the higher trophic levels. So the higher you are up in the energy pyramid, the less energy you're going to have. So to compensate for the decrease in energy, the higher level trophic consumers need to eat more. So for example, a tertiary consumer must eat 10 times more than a secondary consumer, or 100 times more than a primary consumer. It must eat more in order to capture the same amount of energy as the primary and secondary consumers. So if you think about like a lion or a tiger, they're at the top of the food chain. They eat a lot of food because they need more energy, because each thing that they have does not have that much energy in it. Okay? And at some point, it doesn't. That's the point. Sorry. Yeah, they're big animals, so they need a lot of energy first of all. So they have to eat a lot of little things because those little things only have a little bit of energy in them. At
Can I
some
turn
point,
it in?
yeah, when you're done, turn it in. At some point, there is not enough energy to transfer from one level of the trophic pyramid to the next. So that's why food chains cannot go on forever and ever and ever and ever. Okay? All right, I think we're almost done, so you have about 30 seconds here. Alrighty. If you're not done, just make sure you finish it up later. Here's our next slide.
Miss Jones,
Yes.
do you think I can try to make this up at school?
Yes, I think you will be able to.
All right.
Okay. The energy pyramid. The decrease in available energy can be illustrated in an energy pyramid. The base of the pyramid represents the bottom of the food chain, the producers, which is why the plants are all at the bottom. The top of the pyramid represents the top consumer, so the one that's like the top of the food chain. Okay? The levels between the base, the bottom, and the top represent the organisms that feed on each other in the food chain. So the plants at the bottom get eaten by the rabbits on the second level. The rabbits get eaten by the snakes on the third level, and the owl eats the snakes from the third level. Okay? So you can show it in a pyramid, you can show it with arrows. There's lots of ways to do these food chains. Okay? Is there more? Yep, okay. Almost there. All right, about 15 more seconds. Alrighty. Next slide. The energy pyramid will show each level that contains only 10% of the previous level. So if you're thinking about the base of the pyramid, this is your 100% of the energy. Okay, the second level of the pyramid is 10% of the energy left over. The third level is 1% of the energy left over, and the top level is 0.1% of the energy. Okay, so as you go up, the amount of energy in these animals gets smaller. Okay, the base of the energy pyramid is largest. The top of the energy pyramid is the smallest portion. The size represents the amount of energy available in those organisms. So you can even see it with the size of the pyramid itself. the boxes and the levels get smaller, which shows that the amount of energy is getting smaller as you go up. One more? Two more? I don't even know. Give you guys about a minute on this one. Alrighty. Yes, Charlie.
If you have more energy than most people,
Do I?
is that me and like you already have
Potentially, yeah. Because I'm a vegetarian and I don't eat the animals, I might get more energy, yeah. Because I eat plants, a lot of them.
and then
It's pretty easy to go back and forth between vegetarian and vegan. All right, our next slide. The energy pyramid also shows the population size of organisms in each trophic level. Because energy is lost moving up a food chain, each trophic level supports fewer organisms. The largest population is at the base of the pyramid and the smallest population is at the top. So there's more plants in an ecosystem than there are rabbits, and there's more rabbits in the ecosystem than there are snakes, and then there's more snakes in the ecosystem than there are owls. So the population, or the amount of animals in the species, goes down as you go up the food chain. And one more. Elijah.
Miss Jones,
Yes, Alan.
guess how many miles I ran at the walkathon last year?
How many miles did you do?
11.
Okay. I think I did that much too. No, not last year.
I placed fifth
Yeah,
or
no.
fourth. Yeah, it was fifth. Yep. I remember.
Okay. Finish up that slide.
I had fun that day. It was fun. Not just like running, just the whole part of it was fun. Even when Mr. Hernandez got slimed, that was probably the best part. Yep. Yep.
All right. Do we have one more slide? Or are we done? Oh, we're done. Okay. Cool. So,
Are we watching Bill Nye?
no, maybe tomorrow.
Bill
So-
Nye's cool.
There is a video about let's see what it's called. This might be loud.
Good grammar and spelling are important.
I have to skip
But if
this.
you want to
It's
write
the energy
essays
flow
that
song. So, wow, it's already 53 seconds in. Yeah, we'll watch it. Maybe just listen if you're still copy and pasting things over. I'm gonna play it, and once I'm done playing this song, you guys will be able to head out. Okay? So, go ahead and have your microphones off if you're in person. Keep your voices off so that we can't hear you. And here is our energy flow song about energy flowing through ecosystems. Yay, here we go. This might be loud. I don't like it already.
eating the food that's right. We classify vocation. Our neighbors think it's to eat it all. And our bubbles are consuming glass. What carnivore eats is y'all. And scavengers eat all that's dead. Is the flow of food chain goes to the right? Is the flow of food read more closely right? Versus the bad that moves from farm and this energy. Then herbivores eat that and the boys eat both. It's true that carnivores consume all that is beef. So we're following the energy of food. Food changing life for food. Our own food eating move points to the right, that's true. We're starting to learn higher levels too. Food web plus change of food. Lines overlap, they do. Food web show flow of food. We're starting to learn decomposer. Decomposters when you need them right. Breaking down organic sounds. Return material that you see. Bacteria and fungi too. Mold and mushrooms to make us proud. Is the flow of food chain goes to the right? Is the flow of food read more closely right? Versus the bag that moves from farms and this energy. Then herbivores eat that and the boys eat both. It's true that carnivores consume all that is beef. So we're following the energy of food. Food changing life for food. Our own food eating move points to the right, that's true. We're starting to learn higher levels too. Food web plus change of food. Lines overlap, they do. Food web show flow of food. Oh, oh, oh. Oh, oh, oh. Yeah, yeah, yeah. Oh, oh, oh. Everything but food. Primary first to time. Everything is food. Secondary in line. Everything but food. It's tertiary time. Everything but food. Quaternary define. Versus the bag that moves from farm and this energy. Then herbivores eat that and the boys eat both. It's true that carnivores consume all that is meat. So we're following the energy of food. Food changing life for food. Our own food eating move points to the right, that's true. We're starting to learn higher levels too. Food web plus change of food. Lines overlap, they do. Food web show flow of food. We're starting to learn decomposer.
All right. So that would be the end of that.